In this simplified method example, we will use a topographic map. You will need the National Flood Hazard Layer near the area of interest, a topographic map such as the USGS topographic maps available on the UGRC, and a GIS application such as QGIS. The first step is to determine whether this method can be used. The Contour Interpolation Calculator spreadsheet can help us do that. The first step is to determine the contour interval of the topo map. Find the two labeled contours and count the lines it takes to get from one to the other. Here is the contour label 6200. So I'm going to find another bolded contour and I'm going to count the lines in between. 1, 2, 3, 4, and 5 to get to the next contour. The difference between the two bolded contours is 200 feet. So next we'll divide by the number of smaller contours it takes to get there to determine the contour interval. So this is 200 divided by 5 equals 40 feet, which is the contour interval. For this method to be used, the elevation difference between the left and right sides of the floodplain according to the topo map must be less than half of the contour interval. We are going to draw a temporary line that is perpendicular to the floodplain on the upstream side of the area of interest. Click on the New Temporary Scratch Layer button. You're going to name the layer, then choose the geometry type. In this case, we're going to use a line string. Then click OK. It should show up in the layers on the left side of the screen. Right-click on the new layer and select Properties. Here you can change the color and the width of the line so it's easy to see when you draw it. Next, we're going to click on the New Line Feature button, and we're going to draw from left to right looking downstream in a perpendicular fashion on the upstream side of the area of interest. To calculate the elevation of the left side of the floodplain, we need to identify the two contours that straddle the floodplain. The higher contour is the one on the left, and its elevation is 6,000. So we will enter that into the spreadsheet on the left contour, higher contour. The lower contour is only one thin contour line down, so that is 6,000 minus the 40-foot contour interval, 5,960. Next, we need to measure the distance between these two contours. So click the Measure tool, change it to feet, and start measuring between the two contours. This is 102.75 feet. So we're going to enter that in the distance between the contours. Next, we need to measure the distance from the lower contour to the floodplain. So clear your Measure tool and click on the edge of the floodplain and measure to the lower contour along that line. This is about 39 feet, so we'll put that in the cell in Excel. The Excel spreadsheet has calculated the elevation of the left contour. Next, we will do the same thing for the right contour. But as you can see in this example, the floodplain directly intersects the contour of the topo map, so we can read it straight from the contour. This is the same contour that we had for the lower contour on the left side. So this is 5,960. We can type that right into the gray cell. The spreadsheet evaluates whether the difference between the left and the right side of the floodplain is less than 1/2 the contour interval. It gives you a yes or a no on number 4. If it is not, you cannot use this method. If it is, move on to number 5 and you will enter the lower elevation between the left and the right side contours and add 1/2 the contour interval. The right contour is lower, so we will type in 5960. The spreadsheet added 1/2 of the contour interval. The BFE is then 5980. This method can result in some pretty conservative values due to the uncertainty in the method.